In December of 2024, in a quiet laboratory in Santa Barbara, California, a small chip cooled to a temperature colder than deep space did something that had been promised for decades and doubted for just as long. The chip was called Willow, and the people who built it at Google announced that it had crossed a threshold that many physicists had begun to wonder if any machine ever would. As they added more of its fragile working parts, the errors did not multiply and overwhelm it, the way errors had always overwhelmed such machines before. Instead, the errors grew fewer. The larger it became, the more reliable it grew, which is a sentence so gentle and so strange that it is easy to read past it without noticing what it means. For the first time, a quantum machine was behaving less like a delicate experiment forever on the edge of collapse, and more like the beginning of something that could be built. There was another number in the announcement, and it is the kind of number that does not fit comfortably inside the mind. Willow completed a particular test in about 5 minutes. The same test, run on the fastest ordinary supercomputer we have, would take a span of time so vast that the words for it lose their footing, a stretch of years longer than the age of the universe, longer than any word we have for old. Whatever that machine was doing in those 5 minutes, it was not doing it the way our familiar computers do. It was reaching into something wider. And the deeper question, the one that has almost nothing to do with speed and almost everything to do with what kind of place we are living in, is where exactly that work was being done. That is the question this long night circles. Not how fast the machine is, and not what it will one day sell or solve, but something quieter underneath all of that. Quantum computers work only because reality, at its smallest scale, does not behave the way our eyes and hands have always told us it does. To build a machine like Willow, its makers had to trust a description of the world so unlike ordinary life that the people who first wrote it down spent the rest of their years arguing over what it could possibly mean. The machine works. The description that makes it work is not in doubt among the people who use it every day. What remains open still after a century is the simplest and heaviest question of all. What is the world actually like if this is what it takes to compute inside it? Let us begin, though, not with the chip, but with the sky. Step outside on a clear night, far from the glow of any city, and look up. The stars hold still. The old constellations sit where they have always sat, patient and unmoved, the same shapes that shepherds and sailors traced thousands of years ago. The ground is firm beneath you. The air is cool and definite against your skin. Everything you can see and touch has the reassuring quality of simply being there, in one place, being one thing. A stone is a stone. It rests where it rests. If you turn away and turn back, it has not moved and it has not changed, and some deep and ancient part of you counts on exactly that. The world, from where we stand, looks solid. It looks settled. It looks like a place made of things that are somewhere, doing something, whether or not anyone happens to be watching. And for almost everything you will ever meet, that picture holds. It is not wrong at the scale of stones and rivers and the slow wheel of the stars. It has carried every builder and farmer and traveler who has ever lived, and it has never once failed them in the ordinary course of a day. You can pour water and watch it fall. You can set down a cup and return an hour later, and find it exactly where you left it, unchanged, waiting, as faithful as anything can be. The world keeps its promises at this scale, quietly and without exception, and it is right to trust it. But that same night sky, the one that feels so calm and so certain, is built out of something. Every point of light up there, every atom in the stone beneath your feet, every particle of the cool air moving in and out of your lungs, is made of the smallest pieces we know how to name. And down at that scale, far below anything an eye could ever resolve, the settled and definite quality of the world quietly comes apart. Not because it is broken. Because that steadiness was never the whole story. It was the story that things tell when there are enough of them, gathered together, seen from far enough away. Inside Willow, cooled to within a whisper of the coldest temperature that can exist, the makers built their machine out of the opposite of a stone. A stone is one thing in one place, holding one value. The working parts of a quantum computer are not like that at all. Each one is arranged so that it does not have to choose. It can hold what we would ordinarily call two different answers at the same time, not switching quickly between them, not undecided in the way a person is undecided, but genuinely carrying both at once, together, as one coherent state. String enough of these together, and something dizzying follows. A handful of them can hold, all at the same instant, a number of possible combinations so large that writing it out would fill pages. The machine does not run through those possibilities one after another, checking each in turn the way we would. In some sense that no one has fully settled, it holds them all together and lets them work on one another and finds its way through. That is the ordinary explanation, the one you will read in the announcements, and it is already enough to unsettle a quiet mind. A single small object holding every answer at once. Not a metaphor. Not a trick of speech to make a technical thing sound grander than it is. The engineers who build these machines rely on this being literally the case, and their machines only work because it is. When Willow did in 5 minutes what would take an ordinary computer longer than the universe has existed, this was why. It was not simply faster. It was searching a space that our familiar machines can only tiptoe into one step at a time, and it was standing in all of that space at once. Sit with that for a moment, the way you might sit with the size of the ocean or the distance to a star. A machine cold enough to freeze the breath out of the air, small enough to hold in a gloved hand, and inside it, held together in a single held breath of computation, more possibilities than there are grains of sand on every shore of the world. And here is the first soft thread of unease, the one we will follow through the whole of this long night, and it is not loud, and it is not frightening in the way a sudden noise is frightening. It is quieter than that, and slower. If the smallest pieces of the world can behave this way, holding many things at once, refusing to be simply one thing in one place, then what does that say about the stone, and the air, and the still and solid night sky that is made entirely out of those same small pieces? The comfortable answer, the one that has let people sleep peacefully for 100 years, is that the strangeness stays down there. That the odd behavior of the very small somehow cancels itself out, or averages away or hides itself so completely by the time you reach the scale of stones and stars that it might as well not be true up here at all. That the world you can see and touch is allowed to remain exactly as solid as it feels, and the machine in the cold laboratory is a special case, a curiosity, a place where the deep rules of things have been coaxed briefly into the open under conditions so extreme they will never touch your ordinary evening. That answer is comfortable. It may even be right. But it is not, it turns out, as settled as it sounds, and the people who have looked hardest at exactly where the strangeness stops have not found a clean and reassuring line. Because the machine forces a question that will not stay in the laboratory. If one small part of Willow really is holding two answers at once, in a real way and not a figure of speech, then a fair and simple mind wants to know what happens to the other answer when we finally look. When the computation ends and the machine is measured and it gives us, as it must, a single definite result, where did all those other held possibilities go? They were there. The machine needed them to be there. It could not have done its work without them. And then, at the moment of looking, all but one of them are simply gone from view, as if the act of asking the world to be definite is also the act of making it definite, an act that leaves us staring at one clean answer and unable to say, with any confidence, what became of the rest. That is not a question about engineering. The engineering is going well. Willow crossing its threshold, growing more reliable as it grew larger, is a triumph of patient and careful work, and the people who did it have earned the quiet astonishment the rest of us feel. The question that will not settle is older and stranger than any chip, and building better chips only makes it press harder. It is the question of what is actually happening in there, in the space between the machine holding all its answers and the machine giving us one. The mathematics that describes it is not in dispute. It has been checked against the world with a precision matched by almost nothing else we have ever measured. What is in dispute, still, after everything, is what that mathematics is telling us about the nature of the place we live in. And notice gently that this is not only a story about a machine at all. The machine is a doorway. It is the most vivid and expensive demonstration we have ever built of a set of facts that were always true, that were true before there were any machines, that were true when there were only shepherds tracing constellations and wondering what the lights were made of. The atoms in your own body were behaving by these rules long before anyone knew there were rules to behave by. The strangeness was never something we invented and poured into a chip. It was always here, underneath the stone and the air and the still night sky, and the chip is only the first thing we have built that makes us stare at it directly and admit we do not fully understand what we are looking at. There is a temptation, when a subject grows this deep, to reach for large and frightening words, and this is not the night for those. Nothing here is out to alarm you. The stars are still where they were. Your breath is still steady. The stone still rests where it rests. Everything that felt solid a moment ago goes on feeling solid, and it will keep feeling solid for as long as you live, because at the scale of a human life in a human hand, the old comfortable picture works flawlessly, and there is a real and lasting peace to be found in that. The unease we are following is not the kind that keeps you from sleep. It is the kind that comes softly, when you realize that the ground you have always trusted rests on something far stranger and far larger than the ground itself, and that the strangeness was never a threat. It was simply the truth underneath, waiting patiently to be noticed. Over the century since these facts first came to light, the people who understood them best could agree completely on what the machines would do and disagree completely on what it meant. They could predict, to a precision that still astonishes, exactly what any given experiment would show, and then argue late into the night about what that experiment was telling them about reality. Some of them concluded that the world simply does not have definite properties until it is looked at, that the moon, in a sense, is not there in a fixed and particular way until something observes it. Others found that idea unbearable and went looking for a hidden layer of ordinary machinery underneath, some quiet clockwork that would make the world definite again and put the strangeness down to our own ignorance. And a few, quietly, followed the mathematics to its plainest reading, and arrived somewhere so vast that most people set the thought down carefully and backed away. All of these readings will find their place before this night is over. None of them will be handed to you as the answer, because none of them has been proven to be the answer, and honesty at this scale matters more than comfort. What can be said now at the beginning, resting under the same unmoved stars, is only this. A machine was built that held every answer at once, and it worked. And it worked because the world at its smallest scale is not the tidy place our eyes report. The stone is made of that world. The air is made of that world. The light of every star that reaches you tonight began as events in that world, governed by these same unsettling rules, long before it ever arrived to be seen. The solidity we lean on is real, but it is not fundamental. It is what the strangeness looks like from far away, when there are enough small things gathered together that their individual uncertainty smooths itself into the calm and dependable surface we call the ordinary world. So the machine in the cold laboratory in Santa Barbara is not really the subject of this night. It is the reason we can no longer look away. For 100 years the strangeness could be filed under mathematics, something abstract and safely distant, a set of symbols that behaved oddly on a page. But now it has been built. It has been cooled and wired and measured, and it has done in 5 ordinary minutes, a thing that our familiar world says should take longer than the universe has existed. That is not something you can file away. That is something standing in front of you, cold and real and quietly humming, insisting that the description behind it be taken seriously, and the description behind it does not leave the everyday world quite as solid as it felt when you first stepped outside and looked up. To understand any of this, to understand what Willow is holding and where it might be holding it, we have to go down, past the chip and past the laboratory, to the single smallest working part, the one piece that carries 2 answers at once. Everything the machine can do rests on it. Every strange and beautiful and unsettling thing this night has to offer begins in that one small object and the impossible space it occupies, the space between a plain and definite 0 and a plain and definite 1, and the reason it does not have to choose. So let us stay there a little longer, in that small space, and let us see what lives inside it. The ordinary computers we know, the one on the desk and the one in the pocket, and the vast humming ones in cold rooms somewhere far from here, all of them think in a single tidy language. They speak in bits. A bit is the smallest unit of information there is, and it is a very humble thing. It is either a 0 or it is a 1. That is all it can ever be. Every photograph you have ever seen on a screen, every song, every message sent across the dark to someone you love, all of it is written in nothing but these 2 symbols, arranged in long, patient rows, millions and billions of them, each one committed fully to being either off or on, either nothing or something, either 0 or 1. There is a great comfort in this. A bit does not hesitate. A bit does not hold 2 ideas at once. Ask it what it is, and it answers plainly the way a light switch answers, the way a closed door and an open door answer. The machines we are speaking of tonight do not think this way. At the heart of a quantum computer is a different kind of unit, and it goes by the name of a quantum bit, which everyone shortens, gently, to qubit. A qubit is the quantum world's answer to the humble bit, and for a moment it seems almost the same. It too can be a 0. It too can be a 1. If you build it and you leave it alone and then you ask it, at the end, what it holds, it will give you an answer as clean and as definite as any ordinary bit ever could. But in the long, quiet stretch before you ask, in the space between when it is set spinning and when it is finally read, the qubit is doing something that has no honest picture in the world we walk around in during the day. It is being both. Not switching quickly between the two, the way a light flickers. Not undecided, the way a person is undecided, leaning first one way and then the other. It is not that the qubit is secretly a 0 and merely hiding it from us, nor that it is secretly a 1 and playing coy. The physicists have a word for what it is instead, and the word is superposition. A qubit in superposition is not one answer waiting to be found. It is many answers held at once, layered into a single object, a 0 and a 1 existing together in the same small breath, each carrying its own weight, its own share of the whole. Let that settle slowly, the way a thing settles at the bottom of still water. There is an image that has followed this idea around for a very long time, and it is a kind one, so let us keep it near us for the rest of the night. Picture a coin. Not a coin lying flat on a table, already fallen, already decided, already heads or already tails. Picture instead a coin spinning in the air. It has left your hand and it has not yet come down. While it turns, catching the light, blurring at its edges, you could not honestly say it is heads. You could not honestly say it is tails. It is not that the answer is simply unknown to you and known to the coin. In the spinning, in that suspended turning moment, the coin is somehow both faces at once, neither one having yet claimed it. Only when it falls, only when it strikes the surface and stops, does it become a single thing you can name. The qubit is the coin that never quite has to land, right up until the moment we make it. It is worth holding still with that for a breath, because it asks us to give up a thing we have believed since we were very small, the belief that everything must be one way or the other, that a question always has a settled answer, sitting somewhere just out of view, waiting only to be uncovered. In the daylit world, this is nearly always true. The coin on the floor is already heads. The letter in the drawer already says what it says. We do not know it yet, but the answer is there, fixed, patient, real. What the qubit tells us, softly and without any drama at all, is that this comfortable rule has an edge, and that below a certain size the world simply stops obeying it. Down there the answer is not hidden from us. Down there, until we look, there is genuinely no single answer to hide. The small object grows strange now, in a way that is difficult to hold. One spinning coin is one thing. But quantum computers do not work with one qubit. They work with many, and the many do not simply sit side by side, each spinning on its own. They fold into one another. Two qubits together can hold not just a 0 and a 1, but every arrangement of two, all at the same time. The combination that reads 0, 0, and the one that reads 0, 1, and the one that reads 1, 0, and the one that reads 1, 1, all four of these possibilities present together, layered into the same instant. 3 qubits hold 8 arrangements at once. 4 hold 16. And this doubling does not slow down or grow tired. It climbs. Each qubit you add doubles the number of possibilities the machine is holding, doubles the size of the space it is moving through while no one is looking. According to Google's own account of how these machines work, a modest handful of qubits can already hold more distinct possibilities at once than there would be room to write down in any ordinary way. Add enough of them, only a few hundred, far fewer than the transistors in a common phone, and the number of possibilities held in superposition would exceed the number of atoms in the observable universe. The whole cosmos of stars and dust and everything between, all of it outnumbered by the states hiding inside a device you could hold in 2 hands. This is not a way of speaking. This is the plain arithmetic of the thing. And still the machine sits there, cold and quiet, no larger than a chandelier, showing nothing on its surface of the vast interior it is somehow keeping open. A very soft unease rises out of all this the longer it stays with you. Not fear, nothing so sharp as fear. Something quieter than that. The sense of standing near a door that is slightly ajar, and realizing that the room behind it is far larger than the wall in front of it should allow. For a long time this was only mathematics. Beautiful, unsettling mathematics, but the kind that lived on paper, and in the minds of people who thought about such things for a living. The equation said that this many-add-ons behavior should be real. But saying and showing are two different countries, and the gap between them is where science does its most careful and most stubborn work. The question that hung over the whole field for decades was simple to ask and terribly hard to answer. Could a machine built out of these spinning, undecided, many things-add-ons units actually do something, actually finish a task that no ordinary computer, no matter how large, no matter how patient, could ever hope to finish in the lifetime of a star? In the autumn of 2019, a group of researchers said that it had happened. The machine was called Sycamore, and it was built by the quantum team at Google. It was not large. It carried on its small superconducting chip 53 of these qubits, 53 spinning coins held in a cold so deep it is close to the coldest anything ever gets, colder than the empty space between the stars. And in a paper published that October in the journal Nature, the team described setting Sycamore a particular task. It was not a useful task, not in the way we usually mean useful. It was something closer to a very elaborate exercise in randomness, a way of asking the machine to weave its many add-ons states together and then let them fall into a pattern that only such a machine could produce. But that was rather the point. The task was chosen precisely because it played to everything a quantum machine can do and everything an ordinary one cannot. Sycamore finished it in about 3 minutes. To grasp what that number means, you have to set it beside the other number, the one the researchers offered for comparison. They estimated that to reproduce what their small cold chip had done in those 3 minutes, the largest ordinary supercomputer then in existence, a machine filling rooms, drawing the power of a small town, would need something on the order of 10,000 years. 10,000 years against 3 minutes. A span longer than all of recorded human history against the time it takes to soft-boil an egg. The team called this crossing a threshold, and the name they gave the threshold was quantum supremacy. It meant, in their telling, the first moment a quantum machine had done a real thing that lay genuinely beyond the reach of every ordinary machine ever built. Now we should be gentle and honest here, because the story did not end cleanly, and the pretending that it did would be a kind of small lie told in the dark. Not everyone accepted that 10,000-year figure. The researchers at IBM, who build their own quantum machines and know this territory as well as anyone, offered a different reading soon after. With a cleverer way of using an ordinary supercomputer, they argued, the same task might be reproduced in something more like a couple of days rather than 100 centuries. Days is still slow against 3 minutes. But days is not 10,000 years, and the difference matters because it is the difference between a wall that can never be climbed and a wall that is merely very high. The word supremacy, with its air of something final and unbreakable, sat uneasily on the whole affair. Many in the field have since preferred quieter language, and Google itself in its later work leaned toward gentler terms. Hold that carefully. It is a good and useful uncertainty, the kind that keeps science honest. What was demonstrated in 2019 was not the end of any argument. It was a claim, a strong one, that these spinning, layered, many add-ons machines could pull ahead of ordinary ones, and that we had at last reached the edge of that country and taken a single step across. But notice what did not fall into dispute, even amid all the arguing. No one on any side of that debate questioned the qubits themselves. No one suggested that Sycamore was secretly just a very fast ordinary computer, a bit pretending to be more than a bit. The disagreement was about how impressive the crossing was, how far the far side really lay, how long the ordinary machine would truly need. The superposition was never in doubt. The spinning coins were real. Whatever else was uncertain, the strangeness at the center held firm. 53 small objects had each been coaxed into being both of their answers at once, and made to fold their manyness together, and made to compute with all those possibilities held open in the same suspended moment. That part, the astonishing part, no one denied. And this returns us to the quiet unease the door left slightly ajar. Because if the machine truly held all those possibilities at once, if the coins truly spun as both faces together, then a question rises up out of the mathematics and refuses to lie back down. Where did all of that happen? When Sycamore held more distinct states than a small computer could ever list, when its qubits carried their layered manyness through those 3 minutes of cold and dark, where were all those possibilities kept? Not in the small chip alone, surely, for the chip is only a chip, a modest thing of metal and cold, no roomier on the inside than its outside allows. And yet something was being explored in there, something vast, some enormous space of arrangements, sifted through all at once, a space we built the machine specifically to reach into, and that we cannot, with any eye or instrument, actually see. We built the doorway. We know how to open it and how to close it. We can send a question through and receive an answer back, correct and complete. An answer that could only have come from somewhere with room enough to hold all those possibilities at once. But the room itself we have never entered, and there is a growing suspicion, among the people who think hardest about these things, that we never will. Not because the door is locked against us out of some accident of engineering we might one day solve. Something about the very act of looking seems to close the room before we can step inside, as though the vastness exists only on the condition that no one is there to witness it. The machine keeps its enormous interior open precisely by keeping it dark, and we are left standing at the threshold, certain the space is real, certain the work is being done, and unable to see any of it. That is the strangest part of all, and it is the part we will carry forward into the deeper dark. We know the machines work. We can measure that they work. We can set them their impossible tasks and watch the right answers come tumbling out. Answers no ordinary machine could have found in the age of a galaxy. But the great churning middle of it, the moment when all the possibilities are held open at once and worked upon together, that moment happens somewhere we are not allowed to look. Not because we lack a good enough microscope. Something deeper forbids the looking, as we will see. The superposition is real precisely as long as no one observes it, and the instant we try to catch it in the act, to peer directly at the spinning coin and see it being both, it stops. It lands. It gives us one plain answer and folds all its other possibilities quietly away, as if they had never been there at all. So we are left in a peculiar position, half awake at the edge of it. We have built machines that reach into an immense unseen space, that do their real and impossible work inside a superposition we can never directly witness, that answer questions by exploring possibilities we cannot count and cannot watch and cannot fully say where they reside. The machine holds every answer at once, somewhere, and shows us only the one it settles on. Everything vast about it lives in the dark, in the part between the setting and the reading, in the long quiet turning of the coin before it falls. Something is being explored in there that we cannot see. That is the loop we open now and carry down with us into the deeper hours, a thread laid gently across the whole of the night. Something enormous is happening in a place we have no way to observe, and it happens only so long as we do not observe it. Which raises the gentlest and most troubling question of all, the one waiting for us just past this section, at the border of sleep. What happens the moment we do look? What breaks in that immense held open space, the instant a single measurement is made, and the coin is finally forever forced to land? Rest here a while in the space between 0 and 1, and we will go quietly toward the answer. So we look. And in the looking the spell breaks. The coin that was spinning through both faces at once, held open across that vast and quiet interval between 0 and 1, comes down. It lands. It is one thing now, a single definite answer, where a moment before there had been every answer softly overlaid. And the strangeness, the whole gentle impossibility of it, is gone. Not hidden. Gone. As though it had never been there, as though the machine had only ever been holding an ordinary number all along, waiting patiently for us to read it. This is the part that unsettles the physicists more than the superposition itself. Not that the qubit could hold both states, but that the mere act of measuring it, of forcing it to declare, seems to collapse all that openness into something plain and ordinary in an instant. And nobody in the deepest sense knows why. We can describe it. We can predict it with an accuracy that borders on the miraculous. But the why of it, the reason the spinning coin must land the moment we glance its way, remains one of the oldest unanswered questions in all of science. Let us go slowly here, because this is delicate ground, and the mind wants to shove past it toward a comfortable resolution that does not yet exist. There is a word for the breaking of the spell, and the word is decoherence. It sounds technical, and in the equations it is, but the idea underneath it is soft and almost sad. Coherence is the state of the qubit while it is undisturbed, while its two possibilities move together in perfect quiet step, in phase, woven into a single delicate whole. Decoherence is what happens when that weave comes apart. When the threads that were holding hands let go of one another and scatter. And what pulls them apart is not some grand cosmic hand reaching down to decide the answer. It is something far more ordinary and far more relentless. It is the world. It is everything around the qubit that is not the qubit. A single stray photon of light, drifting past, brushing against it. A faint tremor of heat in the metal of the chip. A whisper of a magnetic field from somewhere across the room. A cosmic ray born in a dying star ages ago arriving at last through the ceiling. Any of these, all of these, the countless small touches of an ordinary universe, are enough. The qubit, which had been holding itself so carefully apart, becomes entangled with its surroundings. Its quiet secret leaks out into the wider world, spreading into the air and the walls and the warmth, and once that secret has spread, once it is written into a billion tiny places at once, it can never be gathered back. The openness is lost to the room. According to the physicists who study this, decoherence is the reason the strange quantum world hides so completely from us in daily life. It is why a coin on a table is only ever heads or tails, and never both, and why a cat is only ever one thing, and why the machine on the desk must be shielded and chilled to a temperature colder than the empty space between the stars, held in a silence deeper than any silence we could imagine, just to keep the world from touching it. Because the moment the world touches it, the moment even a single particle carries the news away, the coin comes down and the spell is broken. Sit with the strangeness of that for a moment. The reason reality looks so solid and settled and ordinary all around us, the reason nothing seems to shimmer with impossible possibility, is not that the strangeness was never there. It is that the strangeness is fragile beyond measure, and the world is loud, and the world is always watching. We live inside a constant, gentle collapse. Every surface we touch, every breath of air, every faint warmth on our skin is the universe measuring itself, over and over, moment after moment, forcing every open question closed before it can ever be seen. And yet the mystery does not resolve when we reach this point. It deepens. Because you might think that decoherence is the answer. That we have just explained the whole thing. The qubit gets touched by the world, its secret leaks out, the coin lands, mystery solved. And for a long time some physicist hoped exactly that, hoped that decoherence would be the quiet key that unlocked the whole puzzle and let everyone go home. But according to those who have looked most carefully, it does not quite finish the story. It explains why we stop seeing the two possibilities laid over each other. It explains why the strangeness fades from view. What it does not explain, what nothing yet fully explains, is why we end up with this particular answer, this one landing of the coin, and not the other. Because when the qubit spreads its secret into the world, the equations do not say the coin becomes heads. The equations say the whole world becomes part of the superposition. The room, the chip, the chill, the physicist watching the screen, all of it, in the pure and untouched mathematics, becomes one enormous open question, heads woven together with tails across everything. The equations never on their own choose. They never collapse. They only spread the openness wider and wider until it swallows the observer whole. And yet we always see just one answer. A single number on the screen. One face of the coin. This gap, this quiet and enormous gap between what the mathematics describes and what we actually experience, has a name that physicists say almost in a whisper. They call it the measurement problem. And it has never been solved. Let that settle without hurry, without alarm. The most successful theory in the history of human thought, the theory that gave us the transistor and the laser and the very machine we have been speaking of, the theory that has never once been wrong in any experiment ever performed, cannot tell us what happens when we look. It cannot tell us where the openness goes. It cannot tell us why we see one world and not the endless shimmering overlay its own equations insist should be there. We have built a civilization on top of this theory. We carry it in our pockets. And at its very center, where the looking meets the looked at, there is a hole in our understanding as old as the theory itself, still open, still waiting, still quietly unanswered after nearly 100 years. The physicists have not stopped trying. There are careful thoughts, several of them, each a different way of imagining what might be happening in that instant of collapse. We will come to those thoughts gently, in time, and we will hold each one the way you might hold a smooth stone found on a shore, turning it in the light without deciding it is the only stone. But no honest account can tell you which of them is true. The measurement problem is not a puzzle with a hidden answer that someone clever has already found and tucked away. It is a genuine edge, a place where human knowledge simply stops and the dark begins. Now let us do something. Let us pull back. For this whole while we have been very close. We have been down among the wires and the cold, watching a single qubit hold its single impossible secret, watching the spell form and the spell break. Let us lift away from the chip now, slowly, the way a camera might drift upward and back, and let the small thing become part of a larger picture. There sits the machine, in its shielded chamber, in its laboratory, humming its faint refrigerated hum. And around the laboratory is a building, and around the building a city, going about its evening. And around the city the curve of a turning world, half of it in darkness now, half in the last of the light. And that world hangs in the thin blue skin of its atmosphere around a single ordinary star, and that star is one among a few 100 billion in a slow, bright wheel of a galaxy. And that galaxy is one among a few 100 billion more, scattered across a distance so wide that the light now arriving in our eyes left some of them before the world was formed. And every one of those countless things, every star and every stone and every drifting cloud of far cold gas, is made of the same particles as the qubit on the chip. Every one of them obeys the same quiet equations. Every one of them, at the smallest scale, before the world reaches in to touch it and force the answer, is a spinning coin, an open question, a possibility not yet collapsed. The strangeness we shielded so carefully inside that cold machine is not a rare and delicate thing we manufactured in a laboratory. It is the ordinary fabric of everything. The machine is only unusual in one respect. It is one of the very few places where we have managed to hold the world back long enough to see the fabric before it settles. Everywhere else, in the stone and the star and the sleeping body, the collapse happens too fast and too constantly for us to ever catch it. But it is there. It is always there, underneath. We are all of us, and all of this, made of the space between 0 and 1. And so a question begins to form. A quiet one. It has been waiting patiently underneath everything we have said, and now, in this pulled-back stillness with the whole soft wheel of the cosmos turning below us, it rises. Earlier we asked what happens the moment we look, and we have been circling an answer, or the honest lack of one. The spell breaks. The coin lands. The openness leaks away into the world, and where it goes and why it chooses, we do not know. Let that first question rest now, closed as far as it can be closed, which is to say held open in the only way honesty allows. But a second question has opened in its place. A stranger one. And it is this. When the machine runs, when the qubit holds its every answer at once, and the calculation moves through all those possibilities together in a single quiet breath, where is that actually happening? Consider what the machine does when it works. A quantum computer, at its best, explores an enormous number of possibilities at the same time. Not one after another the way an ordinary machine would, checking each answer in a long patient line, but all together in parallel, all at once. That is the whole reason to build one. That is the promise. For certain problems, a quantum computer with only a few hundred qubits could hold more distinct possibilities in that single overlaid breath than there are particles in the entire observable universe. More states than there are atoms in every star in every galaxy we can see. So where does all that computation take place? Where is the room large enough to hold it? The chip is small. You could cover it with your hand. The number of possibilities it juggles is larger than the cosmos. And they are not stored anywhere we can point to. There is no vast filing cabinet inside the metal, no hidden library of answers. There is only the qubit in its quiet superposition, holding all of it somehow in a way the equations describe perfectly and our imagination cannot picture at all. Some of the people who built these machines have asked this question out loud, and their answers are not comfortable. One of them, considering the sheer size of what a quantum computer computes, wondered plainly where the calculation was being done, since it could not possibly fit inside the tiny thing on the table. And the answer that follows from taking the mathematics at its word, followed all the way to the end without flinching, is one of the strangest things a person has ever probed about the nature of the world. We will not reach for it yet. It deserves more room and a slower approach, and we are not ready. But feel the shape of the question, the way it presses gently outward against the walls of the room and the walls of the sky. Something is being computed that is far too large for the place we are computing it. And it is being computed anyway. And it comes back, every time, with the right answer. Hold both of these now side by side in the quiet. The first, that the world is a constant collapse, that reality wears its solid ordinary face only because it is being measured and measured and measured, endlessly, by everything, and that we do not truly understand what that measuring is or why it lands where it lands. And the second, that when we shield a small piece of the world from all that measuring and let it stay open, it performs feats of computation so vast they seem to require more room than the entire universe provides. These are not fringe ideas whispered at the edges. They sit at the very center of the most tested theory we have ever built, unresolved, unhidden, waiting. The physicists live with them the way you live with the deep ocean, aware that just beneath the thin lit surface where the boat floats, the water goes down and down into a dark that has never been fully seen. And we have not yet reached the strangest part, because so far we have only described the mystery. We have said what happens and admitted what we do not understand about why. But there is a way to test it. There is a way to take the softest, most philosophical-seeming question, the question of whether the coin was secretly heads all along and only pretending to spin, and put it to a real experiment with real machines in a real laboratory, and force the universe itself to answer. It sounds impossible. For decades it was thought to be impossible, a matter of pure interpretation, forever beyond the reach of any measurement. And then someone found a way. A way to ask reality directly, whether the openness is real, whether the coin truly has no answer until we look, or whether the world has simply been keeping a secret from us the whole time, hiding a definite answer beneath the shimmer. The experiment was performed. It has been performed many times now, more and more carefully, closing every loophole, tightening every gap, until there was nowhere left for a comfortable answer to hide. And a little over 100 years after the whole strange story began, the people who first thought to ask reality this question were given the highest honor in science for what they found. What they found does not let us keep the ordinary world we thought we lived in. It forbids it. Softly, precisely, and beyond any reasonable doubt, it rules out the comforting picture, the one where things are simply what they are, whether we look or not, where the coin was always heads and the strangeness was just our ignorance. That picture is gone. The experiment closed the door on it, and the door will not open again. Come with us quietly to that laboratory and to the question they asked, and to the answer the universe gave back. The laboratory is not a place of thunder. It is quieter than the room where you are lying now. There are optical tables, heavy slabs of steel resting on cushions of air, so that even a footstep in the hallway will not disturb the light traveling across their surface. There are lasers, thin threads of it, folded and refolded by mirrors. There are crystals no larger than a fingernail, and detectors cooled and patient, waiting for the arrival of single particles of light. And there is a question, older than any of the machines, that hangs in the still air above all of it. The question is this: when we are not looking at the world, is the world already there, already decided, wearing its properties the way a stone wears its weight? Or does the world hold back, keeping its answers folded until the moment we ask? For a long time this seemed a question for philosophers, the kind of thing you might turn over on a night like this one, and set down again by morning, unanswered and unanswerable. It felt too soft to test. There seemed no experiment you could build, no dial you could turn, that would ever separate a universe that was quietly real when unobserved from a universe that was not. The difference lived somewhere beyond the reach of any instrument. And then, in the middle of the last century, a physicist named John Bell found a crack of light in that certainty. He worked out on paper, with nothing more than careful reasoning, that the two universes were not the same after all. They made different predictions. Faint ones, but real ones. If reality was the comfortable kind, the kind that is always already there, then certain correlations between distant particles could only be so strong, and no stronger. There was a ceiling, a limit, a line the numbers were forbidden to cross. He wrote that limit down as an inequality, a mathematical fence, and the fence came to carry his name. A Bell inequality is not a difficult thing to picture, once you set the equations aside. Imagine two particles born together from a single event, twins in the truest sense, and then sent flying apart, one to the left, one to the right, until they are far from each other. You measure something about the particle on the left. Your colleague, standing at a distance, measures something about the particle on the right. You each write down what you find. Then you do it again and again with fresh pairs, thousands of times, and afterward you sit together and compare your two columns of results. If the universe were the comfortable kind, If each particle carried its answers with it from birth, like a sealed letter to be opened at the detector, then the agreement between your two columns could rise only so high. That was Bell's ceiling. But quantum mechanics predicted something else. It predicted that the columns would agree more often than any sealed letter could allow. It predicted a correlation that no shared past, no hidden instruction packed into the particles at birth, could ever produce. Two theories, then, pointing at the same fence. One said the numbers must stay below it. The other said they would climb over. All that remained was to build the experiment and look. And this is where the three names enter, the names that would, decades later, be gathered up together and honored. In 2022, according to the Nobel Foundation, the Nobel Prize in Physics was awarded to Alain Aspect, John Clauser, and Anton Zeilinger for their experiments with entangled photons, for establishing the violation of Bell inequalities, and for pioneering the science of quantum information. Say those words to yourself as you drift entangled photons and let the strangeness of them settle. Entanglement is the name we give to that twinned condition, when two particles are so bound in their origin that they can no longer be fully described on their own. Neither one has its own separate story. They share a single story between them, stretched across whatever distance divides them. John Clauser was among the first to bring Bell's paper down out of the realm of thought and into the realm of glass and wire. He took atoms of calcium and coaxed them, with the right light, into releasing pairs of photons, twin particles of light flying off in opposite directions. On each side he placed a filter, a gate that would let a photon through only if it was oriented a certain way, and behind each filter a detector to catch what passed. Then he counted. He counted the agreements and the disagreements, pair after pair, and he watched to see whether the numbers would stay below Bell's ceiling or rise above it. They rose above it. The fence was crossed. But a single crossing, in the careful world of physics, is never quite enough. There were always doubts to answer, small doors left ajar, through which the comfortable universe might still slip back in. Perhaps the two sides of the experiment, the left and the right, were somehow whispering to each other, some signal passing between the detectors that let them coordinate their results. Perhaps the particles, in some subtle way, could sense in advance how they were about to be measured, and arrange themselves accordingly. These were the loopholes, and each one was a way the old, settled picture of reality might survive. So the work went on. In the early 1980s, Alain Aspect and his colleagues refined the experiment into something more airtight. They found a way to change the orientation of the filters while the photons were already in flight, deciding how to measure each one only after it had left its source, so quickly that no signal traveling at the speed of light could carry the news from one side to the other in time to matter. If the two detectors could not possibly be talking to each other, and the correlation still climbed over the fence, then the whispering explanation was dead. The correlation still climbed over the fence. And then Anton Zeilinger, over the years that followed, took the whole enterprise further still, closing loopholes, sharpening the tests, and beginning to work with systems of more than two entangled particles, at once three of them, then more, all bound into a single shared condition. He and others turned entanglement from a curiosity into a tool, a resource you could steer and use, laying the groundwork for the quantum technologies we spoke of earlier. But underneath all the applications, the same old question kept its place. And with each new experiment, more careful than the last, the answer came back the same. The fence is always crossed. Now understand what this means, as far as it can be understood, here in the dark. Bell's inequality was not a test of quantum mechanics against nothing. It was a test of quantum mechanics against a specific and deeply reasonable picture of the world, a picture so natural that most of us carry it without ever noticing we are holding it. That picture has two parts, and physicists gave them plain names. The first part is called locality, the idea that nothing here is affected by something far away without something crossing the distance between, that a thing can only be touched by what is near to it. The second part is called realism, the idea that things possess their properties whether or not anyone is looking, that the answers are there in the particle all along, waiting to be read. Locality and realism together. The world is out there, and it is out there independently, and the far parts of it cannot reach across empty space to grip the near parts without something traveling between. This is the comfortable universe. It is the universe your body assumes when you walk across a room. It is very nearly the universe of common sense itself. And the Bell experiments ruled it out. Not both parts at once, necessarily. That is the delicate thing, the thing to carry gently into sleep. The experiments do not tell us which of the two comforts we must surrender. They tell us we cannot keep them both. Either the world is non-local, and distant things are bound together in ways that do not respect the space between them. Or the world is not real in the old sense, not carrying its properties independently of measurement, holding its answers folded until they are asked for. One of these at least must be true. Perhaps both. But the two together, locality and realism, cannot stand. The universe has closed that door. Non-locality is the stranger of the two, and it is worth sitting with for a moment, softly, without alarm. Return to the twins, the paired particles flung to opposite ends of the room, or the opposite ends of a city, or in some experiments, opposite ends of a distance far greater than that. Before either is measured, neither has a definite answer to give. They exist in that blurred condition we have followed all through this night, the condition of not yet decided. Then one is measured. In that instant, it settles into a definite state. And the other, its distant twin, settles too into the matching state, as if it had known. Not some time later, once a signal could have crawled across the gap at the speed of light. In the same breath. Nothing passes between them as far as anyone can find. No signal, no whisper, no thread you could ever use to send a message. You cannot exploit it to speak across the void. And yet the correlation is there, perfect and immediate, stronger than any shared past could account for. The two particles behave as though the distance between them were, in some quiet way, not entirely real. As though space itself were thinner than it looks, or the boundary between here and there less solid than the room around you suggests. This is what the light told the three careful watchers in their still laboratories. This is the answer the universe gave back to the question they asked. And it is not a shout. That is the thing to understand as you lie here. It is not a shock, not a rupture. It is a small, precise closing of a door, the loss of a picture we did not know we were holding until it was taken from us. The comfortable universe, the one that is simply there, decided and separate and local, is forbidden. And it went without a sound. What then is left standing in its place? Here the physicists part ways, and it is important to hear this clearly, because the mystery is real and the certainty stops at a definite edge. The experiments tell us what the world is not. They do not tell us cleanly what it is. Into that gap flow the interpretations, the different stories physicists tell to make sense of the same undisputed numbers. And these stories are not settled. They are not proven. They are ways of reading a text that everyone agrees on, and reasonable people, brilliant people, read it differently. One reading goes further than most, and it is the one we will follow toward the deepest room of this night. Some physicists look at the way quantum systems seem to explore many possibilities at once, the way a quantum computer appears to hold a vast field of answers in a single spread-out state, and they draw a startling conclusion. They ask where all that computation is happening. If a machine is somehow evaluating an enormous number of possibilities together, where is the room for it? Where do all those parallel paths reside? The physicist David Deutsch has argued, in his writing on the foundations of the subject, that the most natural place to put them is in other worlds. That the possibilities are not a mathematical fiction bookkeeping our ignorance, but are in some sense real, each unfolding in its own branch of a reality far larger than the single thread we experience. On this reading, the blur we have been calling a superposition is not one particle being vague. It is the shadow, cast into our world, of many particles in many worlds, all of them equally real, all of them going about their business alongside our own. This is the many worlds picture, and it must be set down here with great care. It is one interpretation. It is not the only one, and it is not confirmed. Other physicists find it extravagant, a heavy price to pay, and they prefer readings in which the branches never become real, in which the world stays single, and the strangeness lies somewhere else, in the act of measurement, or in the mathematics, or in limits on what we are ever allowed to know. The numbers do not choose between them. The experiments do not choose. Each reading is a way of standing before the same closed door and imagining what lies on the other side, and no instrument yet built can walk through and report back. So we hold it loosely, the way you hold a thought at the edge of sleep, present but not gripped. The comfortable universe is forbidden. That much the light has told us, and told us again in laboratory after laboratory, more surely than almost anything else in physics. What replaces it is a landscape of possibilities, some gentler, some vast beyond easy imagining, and among them, offered by some who study these things, a picture in which every unmeasured possibility is a world of its own, and our world is only one. Lie with that for a moment. Not the fear of it, but the size of it. The particles in the walls around you, in the air you are breathing, in the slow machinery of your own resting body, are all of them, in their smallest parts, playing by these rules. Entangled with things they have touched. Holding their answers folded. Bound perhaps to distant partners across gaps that do not seem to weigh on them. The comfortable universe, the one that is simply and separately there, was never quite the one you lived in. It only looked that way from the human height in the ordinary light of day. And if the deepest of these readings should turn out to be true, if the possibilities are as real as they are numerous, then the single life you are settling down to rest inside tonight is not the whole of the story. It would be one thread among an unimaginable weave, one branch chosen from a tree whose other limbs run on without you, each carrying a version of this same room, this same descent towards sleep. The state that a quantum system holds does not grow by a little as you add to it. It grows by doubling and doubling and doubling again, until the number of possibilities folded into even a modest arrangement exceeds anything the visible cosmos could hold. Where all of that lives, and whether it lives at all, is the question waiting in the last dark room ahead. We have seen the door close on the comfortable world. Now we go to stand at the edge of what opened in its place, and to ask what it might mean to be a single branch among countless others, resting, unbothered, on the surface of something far larger than we were ever built to see. So let us stand at that edge and look, without flinching, at the shape of what has been left behind. The old picture told us that the world was made of small solid things, arranged in space, each with its own position and its own truth, waiting patiently to be found. Under that picture, to measure something was only to lift a curtain on a fact that had been there all along. The particle already had its answer. We simply had not yet looked. That was the comfort we lived inside without ever noticing it was a comfort. And the experiments we have followed through the last hours have, with great care and great finality, taken that comfort away. What they leave in its place is harder to hold, and it is worth holding without hurry. The correlations that entangled particles show, measured far apart in laboratory that could sit on opposite sides of a city, or in principle on opposite sides of a world, are stronger than any story of hidden instructions could ever allow. Alain Aspect, John Clauser, and Anton Zeilinger were honored with the 2022 Nobel Prize in Physics for showing exactly this, that the inequalities named after John Bell are violated, that no set of pre-written answers carried inside the particles could reproduce what we see. The world does not keep its facts tucked away in advance. Two particles, separated by any distance you like, behave as one thing, as though the space between them were a formality rather than a wall. The phrase physicists use for what has fallen is local realism, and it is worth taking both halves of it apart, because both halves are things we assumed without ever choosing to. Realism is the idea that properties exist before they are measured, that the world is definite whether or not anyone looks. Locality is the idea that nothing here can instantly touch something there, that influence travels, that distance protects. The experiments tell us we cannot keep both. At least one of these two comforts, and perhaps both together, is not how the world is built. Reality, in the phrase that has followed these results out of the laboratory and into the wider world, may not be locally real. Say that to yourself in a low voice and let it settle. The table your hand rests on, the room around you, the weight of your own body pressing down into the bed, all of it is assembled out of particles that at their foundation do not carry definite answers waiting to be read, and do not honor the separations that seem so obvious to us. The solidity is real in the only sense that matters to a body. You will not fall through the floor. And yet the floor, followed all the way down, is not the settled, self-contained bedrock we always took it to be. It is an approximation. A smooth surface laid over something that does not behave like a surface at all. We spend our lives walking on the top of it and calling it the ground. Consider for a slow moment what it means that distance may not protect. In the world we were made for, far apart means safe, unable to reach. A thing here and a thing there are two things, and whatever binds them must cross the gap between, taking time, weakening with the miles. That intuition is written so deep in us that it feels less like a belief, and more like the floor of thought itself. The entangled particles do not respect it. Measure one, and the other is decided in the same breath, however wide the gap has been opened, with nothing passing between them that any instrument can catch. It is not that a signal races across faster than light. It is that the two were never quite two in the way we meant. The separation we saw was real to our eyes and beside the point to the world. What looked like a distance was, at the level that matters, a single arrangement wearing the appearance of two. This is the deepest thing the machines have been showing us, told in a different language. A quantum computer does not merely hold a few possibilities. With each qubit it adds, the number of possibilities it carries does not grow by one. It doubles. 2 qubits describe 4 states at once, 3 describe 8, 10 describe more than 1,000, 20 describe more than 1,000,000, and a few hundred qubits describe a space of possibilities larger than the count of atoms in the visible universe. This is not a figure of speech and not an exaggeration. It is the plain arithmetic of doubling, carried out a few hundred times over. Somewhere, in the working of a device that would fit on a table in an ordinary room, a number of distinct possibilities are being carried together that no volume of ordinary matter could ever store, no warehouse, no planet, no galaxy of hard drives. And the strangeness is not only in how many possibilities there are. It is in how they are held. They do not sit in separate drawers, one beside the next, each waiting its turn to be examined. They overlap. They add together and cancel each other out, reinforcing here and erasing there. The way ripples crossing a pond can lift into a high crest in one place and flatten into stillness in another. The whole art of building one of these machines is to arrange that dance so the wrong answers cancel themselves into nothing, and the right one is left standing when the looking finally comes. The device does its work inside the overlap, inside the place where all the possibilities are present at once, and none has yet been chosen. That is the engine. That is the thing that no ordinary machine can do, and it runs on the very feature of the world that our old picture said could not exist. So we are led, without any way to refuse it, to a question that has no comfortable home. Where do all those possibilities live? When the machine holds every branch of a calculation at once, before anything has been read, before the spell has been broken, in what place are they being kept? The equations do not hesitate. They describe the whole vast fan of possibilities evolving together, each one as real inside the mathematics as any other, none of them marked as the true one and the others as shadows. It is only when we look, only when we ask the world for a single answer, that the fan seems to fold shut and hand us one. The mathematics carries a universe of branches. Our experience carries one thin strand pulled out of it. Physics has never agreed on what that means, and it is important to be honest that it still does not. What we have are interpretations, ways of telling the story that all fit the same measurements, and none of which anyone has been able to prove. They can be laid side by side like different maps of a coastline no one has ever walked, each one faithful to the same shoreline, each one drawn by a different hand, and no way to stand above them all and see which map matches a land that will not let us visit it. One of them, the oldest and the most widely taught, says that the fan of possibilities is real right up until the moment of measurement, and then it genuinely collapses. If you look, the particle is a spread of maybes, a smear of could be. When you look, one of them becomes the fact, and the rest simply cease to be. This is the Copenhagen way of telling it, and its comfort is that it leaves us with a single world, one history, one thread of events we can call ours. Its unease is that it never quite says what a measurement is, or why the act of looking should carry such a strange and privileged power, or where exactly the line falls between the small things that shimmer with possibility and the large familiar things that stubbornly refuse to. It draws a border across reality and cannot tell us where the border runs. Another way of telling it refuses the collapse entirely. In this account, nothing ever folds shut. The fan of possibilities keeps opening forever. When you measure the particle and find one answer, it is not that the other answers vanished. It is that you, the one looking, have become part of the spreading fan. There is now a version of you that saw this outcome and a version that saw that one, each carried on its own branch, each certain it saw the single real result, neither able to reach across and touch the other. This is the many worlds way of telling it, and its odd mercy is that it keeps the mathematics whole and asks for no mysterious act of collapse anywhere. What it asks instead is far larger. It asks you to accept that the single world you feel yourself living in is one leaf on a tree that never stops dividing, that every unlooked outcome is somewhere lived by someone who is also you, that the universe you call the universe is a single branch among countless others, uncountable and unreachable, and every one of them as solid to its own inhabitants as this one is to you. Sit with that phrase for a moment, a single branch among countless others, and notice that it is not a threat. It changes nothing you can touch. On every branch, the tea is warm, the lamp is on, the body settles into rest exactly as it does on this one. No version of you can visit another, and no other can visit you. The branches do not collide or crowd or compete for the same small room. They simply are, each running forward on its own, and yours is the only one your looking will ever hand you. There is a vastness in the thought, but it is a vastness that leaves the ordinary evening untouched, the way the size of the ocean leaves the water at the shoreline, gentle against the feet. And there are other tellings besides these two. Some describe the world as though the answers were always definite, but a real and hidden wave rides underneath, guiding each particle silently along a path already laid. Some describe it as though probability itself, the honest confession of what a watcher can and cannot know, is the whole of the matter, and there is simply nothing further to ask. Some hand the strangeness to the mind of the observer, and some labor to remove the observer altogether, and let the world decohere on its own. None of these has won. No experiment yet performed can stand between them and rule. They agree, everyone, on what the instruments will read tomorrow morning. They disagree only on what is true beneath the reading, and beneath the reading is precisely the place we have found we are not permitted to go. The measurements are a shared front door, and behind it the houses are laid out in ways that have never once let a visitor in. That is the shape of the dread, if we choose that word for it, though the word is too sharp for something this slow and this bloodless. It is not the fear of a thing that might harm you. Nothing here reaches out to touch a single hair on your head. It is the calmer recognition that the ground you assumed was final is not final, that the world you were built to trust is solid and single and settled is, in the only description that has never once failed a test, something else entirely. A surface. A branch. An approximation of a vastness that does not behave the way surfaces and branches and single settled things behave. The most careful people alive have looked as hard as looking can be done, with instruments of astonishing precision and minds of astonishing patience. And the answer they keep arriving at is that the full truth of it sits somewhere we cannot follow. Not because our tools are too crude, and not because we have not tried long enough. Because the very act of following, of looking, of asking the world for one answer, is itself the thing that hands us one answer and folds the rest away out of sight. The question we have carried since the beginning, the second of the two we opened, was where all the held possibilities go when the machine is left alone to compute. We can now say what the honest answer is, and how little it resembles the answer we wanted. They go, in the mathematics, nowhere at all. They are all there, the whole exponential fan of them, evolving together in a space too large to picture and too strange to visit, and it is only our looking that ever reduces the fan to the single strand we experience as the real one. Whether that reduction is a true collapse, with the other strands genuinely ending, or a splitting we ride along a single branch of, with the others going on without us, or something no one alive has yet learned to say, is the exact thing that cannot be settled from where we stand. The loop we opened closes on an answer that turns out to be the shape of a door. Open, unlocked, and leading somewhere the body was never made to walk. And so we come to rest where the last turning brought us, at the edge of the comfortable world, looking out over what replaced it. There is no alarm to sound and nothing that must be done. The floor still holds under the weight of the night. The dark still folds itself around the room the way it always has. The particles that make up your resting body go on being whatever they are, undisturbed by the fact that no one has ever agreed on what that is, indifferent to the question, needing no answer in order to hold you gently where you lie. You are, on the most rigorous account anyone has ever managed, a pattern riding a single branch of something without edges, resting on a surface that is smoother in your experience than it has any right to be in truth. There is a strange relief buried inside that, once the first chill of it has passed through and gone. If the ground is not the final thing, then the smallness we so often feel pressing on us is not the final thing either. We are not tiny separate specks marooned on the one solid stage, watched over by nothing. We are made of the very vastness itself, the same shimmering, branching, unlocatable stuff that fills the machine and the sky and the space between the particles, no more cut off from it than a wave is cut off from the sea that lifts it. The dread, held long enough and softly enough, without gripping it and without pushing it away, begins to turn on its own. It loosens at the edges into something that is not fear at all. Something nearer to awe, and then nearer to a kind of peace that asks nothing of you. And it is toward that turning, away from the vast strangeness and into a way of resting easily inside it, that we drift now, as the night deepens and the mind loosens its last grip on the need to understand. And so we arrive softly at the place the whole long night has been leaning toward, which is not an answer but a way of resting inside the absence of one. The strangeness is real. We have followed it as far as anyone can follow it. Past the cold chip in the Santa Barbara laboratory, past the single working part that carries two answers at once, past the moment when looking folds the many into the one, past the careful experiments that took away the comfortable world and would not give it back, out to the edge where the mathematics describes a fan of branches too wide to picture. And having followed it all that way, we are permitted at last to set the following down. Not to solve it. Only to stop carrying it as though it were a weight. Consider, before anything else, how little the strangeness ever needed us. It was here before there was a single eye to notice it. The atoms that make up the stone and the sky and the slow-breathing body were already behaving by these rules when the first shepherds traced the constellations and wondered what the lights were made of, and they were behaving by these rules for an unthinkable stretch of time before that, before there were shepherds, before there was breath, before there was any looking at all. The world did not begin to be uncertain when we discovered its uncertainty. It did not start branching when we first wrote down the equation that describes the branching. All of it was already the case, entire and untroubled, running on beneath the surface of every ordinary afternoon that ever passed, indifferent to whether anyone ever came to see. There is a great and settling calm in that, once it is truly taken in. The thing that unsettles us was never waiting to unsettle us. It was simply there, being what it is, as unbothered by our noticing as the deep ocean is unbothered by the boats that cross its surface. We tend to feel, when a truth this large arrives, that something has been done to us, that the ground has been pulled away, that a floor we trusted has been revealed as a trick. But nothing was done to us. Nothing changed at the moment we understood. The floor is exactly as it was this morning, and it was exactly this way 10,000 mornings ago, and it will be exactly this way long after this particular night has been forgotten. What changed is only that we now know a little more about what the floor has always been resting on. And knowing more about the deep structure of a thing does not make the thing less trustworthy. It makes it, if anything, more astonishing that it holds you as gently as it does. The chair still bears your weight. The dark still folds around the room. The night still keeps every one of its old and simple promises, and it keeps them now with the added grace of being far stranger and far larger underneath than you ever needed it to be. There is a way of receiving all of this that turns the dread over on its still hinge and reveals something else entirely written on the other side. The dread, when we first met it, was the feeling of being small and separate, a single fragile speck of definiteness marooned on the one solid stage, surrounded by a vastness that did not include us and did not care. That is how the mind first tells the story to itself, and it is an understandable story, and it is not the truest one. Because the vastness is not out there, holding itself apart from you, watching from a cold distance. You are made of it. The same shimmering, branching, unlocatable stuff that fills the machine and the space between the stars and the gap between two particles that behave as one across any distance you like. That same stuff is what your resting body is built from, all the way down, without exception and without seam. You are not a separate thing set down upon the vastness. You are the vastness, folded for a while into the particular shape that is you, doing for a time the particular thing that is being alive and lying here and letting the day come to its close. Feel for a moment how different that is from being small. A wave is not small against the sea. A wave is the sea, lifted briefly into a shape, carrying the whole depth of the ocean in its rising and letting it settle again in its falling, never once cut off from the water that makes it, never for an instant a separate thing that has to defend itself against the size of everything around it. The wave does not have to understand the sea in order to belong to it. It does not have to hold the whole ocean in its mind before the water is allowed to carry it. It simply rises where the deep motion lifts it and rests when the motion eases, and is the sea the entire time, in the rising and in the resting alike. You are like that. The branching that the mathematics describes, the countless possibilities held together in the machine and, if the boldest reading is right, in the world itself is not a foreign country you have been exiled from. It is the country you are a native of. It is the deep grammar of the very matter you are made of. To belong to something that vast is not to be diminished by it. It is to be held at the level below all levels, inside an order so wide and so old that nothing in it is ever truly alone, because separation itself, as the experiments showed us, turned out to be more appearance than fact. And what holds a whole ocean together can surely be trusted to hold the small and settling shape of you. That is the gentlest thing the long night has to offer, and it is worth saying plainly before the mind lets go for sleep. What looked like a distance was, at the level that matters, a single arrangement wearing the appearance of two. The particles far apart were never quite two. And if the world is woven that finely, if the seeming gaps between things are so much thinner than they look, then the loneliness a person can feel, lying awake in the dark, imagining themselves a tiny isolated point in an enormous and uncaring cosmos, is built on the very picture the experiments dissolved. You are not a point. You are a place where the whole vast weave passes through and takes a shape for a while. The dark around you is not the emptiness between you and everything else. It is the same continuous fabric, unbroken, running from the bed you lie on out to the farthest light in the sky, and you are stitched into it as surely as any star. There is one last thread to gather in, the smallest and stillest of them, and it closes the loop we opened at the very beginning of the night, when the machine did in 5 minutes what our ordinary world says should take longer than the universe has existed. We asked then where the work was being done. We wondered what kind of place we must be living in for such a thing to be possible. And now, having gone all the way down and all the way out and all the way back, we can say the one honest thing about the machine that survives every argument over what it means. The machine never showed us anything new. Not one thing. It did not create the strangeness. It did not summon the branching into being or invent the uncertainty or conjure the deep behavior of the very small. Everything the chip revealed was already there, always, underneath the most ordinary day you have ever lived. The machine was only the first thing we ever built that made us look. It is a window, not a source. It held up to our eyes, cold and humming and undeniable, a truth that had been sitting silently beneath the stone and the air and the still night sky since long before there was anyone to be surprised by it. The universe was always doing this. We simply had not yet made the instrument that would force us to notice. And once that lands, something in the chest loosens that has been faintly clenched since the first strange fact of the night arrived. Because if the machine only showed us what was always the case, then nothing has been taken from the world, and nothing has been added to it, and there is nothing new to fear. The world you fell in love with as a child, the firm ground and the cool air and the patient stars, is the identical world, unchanged in a single particular, that the experiments have been describing. It was always this deep. It was always this wide. It was always this gently strange beneath the surface, and it always held you anyway, without asking you to understand it, without needing your permission or your comprehension, in order to keep you safe and warm on through every night you have ever slept. The understanding we reached for was never the thing that kept us. The world kept us. The understanding is only a late and beautiful gift, arriving long after the keeping had already been given, freely, for nothing, all along. So let the need to understand loosen now, the way the outline of a room loosens as the eyes begin to close. There is no problem here that your mind has to solve before it is allowed to rest. The physicists themselves have not solved it, and they sleep. The interpretations sit side by side, none of them proven, all of them faithful to the same shoreline, and the people who spend their lives among them lie down each night on the same unresolved earth, and are held by it exactly as well as anyone. You are not being asked to decide whether the branches are real, or where the possibilities go, or what a measurement truly is. You are being asked only to notice that the question can be set down, softly, at the edge of the bed, and picked up again tomorrow if you wish, and that the setting down of it costs you nothing, and gives you back the whole open evening to rest in. There are more slow journeys through the dark waiting on the channel, whenever you wish to return, more long nights of following a strange and beautiful thing gently down towards sleep. But there is nothing further you need tonight. Tonight the following is finished, and what remains is only the resting. So let the mind begin its slow release. Let it stop reaching, stop gripping, stop trying to hold every branch and every possibility in a single tired grasp. You do not have to hold them. They are held already, held by the same deep order that holds the stars in their slow wheel, and the particles in their unlikely dance, and the breath moving in and out of you without your effort or attention. Let your thoughts loosen the way the machine's held possibilities loosen when the looking finally stops, spreading out, softening, no longer needing to resolve into any single definite answer. There is no measurement being asked of you now. There is nothing here that has to collapse into one clean fact before you are permitted to let go. You can lie in the whole soft spread of it, undecided and unhurried, the way the world itself lies before anyone looks. Picture, if it helps you drift, the surface you are resting on, and then let the picture deepen. You are lying on the bed, and the bed rests on the floor, and the floor rests on the ground, and the ground rests on the slow-turning body of the world, and the world rests on nothing at all, held in the wide dark by the same silent order that holds everything. And all of it, every layer, is the smooth outer face of something vaster underneath, the calm surface laid over the branching depth, the still sky spread over the shimmering foundation that never stops moving and never disturbs the stillness above it. You are sleeping on the surface of something vast, and the vastness is kind, and it does not reach up to trouble you. It only holds. It is always only held. Let the edges of the room go first. The corners softening, the walls receding, the small definite shapes of the ordinary evening, loosening their outlines and letting the darkness in among them, gently, the way water fills a shape without force. Let the weight of the body grow heavier and easier at once, sinking a little further into the mattress with each slow breath, each exhale releasing a little more of the day's holding, a little more of the need to be one settled thing in one settled place. You can let that need go now. The world does not require it of you. Down at the level of the very small, nothing is ever asked to be only one thing, and you are made of that level, and you are allowed the same soft freedom as you fall. And let the mind widen as it loosens, not narrowing toward a single point of worry the way it does in the anxious hours, but opening outward, spreading like the fan of possibilities the machine holds when no one is looking, easy and unresolved and complete. Let it drift out past the walls, out past the roof, out past the glow of any city, up into the still air where the old constellations sit where they have always sat, patient and unmoved. And let it keep going, gently, out past the nearest lights and into the deep dark between the stars, the dark that is not emptiness but continuous fabric, the same weave your body is stitched into, unbroken all the way out and unbroken all the way back to the warm shape resting on the bed. You are held at both ends of that thread, and everywhere along it, and there is no distance in it that can separate you from anything, because the distance itself, when we looked, turned out to be so much thinner than it seemed. Rest there, on the surface of the vast and gentle thing. Let the wide dark be a blanket and not a void. Let the branching go on, branching somewhere far below the reach of thought, doing what it has always done, needing nothing from you, disturbing nothing in you, while the surface you lie on stays smooth and still and warm. The stars hold their places. The floor holds its weight. The deep order holds the whole of it, and holds you within the whole, folded for this one night into the shape of someone falling softly asleep. There is nothing left to understand. There is only the resting and the dark, and the vastness underneath, cradling the small warm surface of your sleep the way the sea cradles the last slow settling of a wave, until the shape lets go, and the water is only water, and everything is still.